How's it going, everyone? Eulio Gonzalez here, and in today's we're going to take a look now at what generators are and how, by combining is the concept of iterators and generators, how can we now understand what's doing and what's going on behind the scenes when using the async and await syntax. You might wonder why this is important, especially because if you want to know how the asynchronicity works behind the scenes in JavaScript, it is important to first, take a look at the fundamentals. And from there you look at how now the asynchronicity plays out in JavaScript, a particularly now approach when it comes to accessing data through iterators, and now how we think on control of data with generators. And by combining these two concepts with the JavaScript fundamentals on asynchronicity, as well as the language itself, now how async and awaits works behind the scenes as a way to now provide this network operations, this ability to write asynchronous code that look like synchronous. So this is somewhat pretty much like the object-oriented programming in JavaScript, especially when you want to write class, when you want to use class. Behind the scenes, there is a lot of inner machinery that's going on, but you are now able to write code that look like class, which is this facade syntax, but behind the scenes is now using is the prototypal inheritance. And in the case of the async and await, again, it looked like that you're writing code that synchronously, but behind the scenes is using now is some of these built-in objects like iterators and generators. So this is something very, very interesting. Today's video, we're going to focus our attention on that, to generators and how we make sense of the generators. Okay, so the goal of this course, which is taught by Will Sentence, shout out to Will Sentence, the CEO of Codesmiths, this software engineer and machine learning residency headquarters in New York and California, is to, by looking now at the ES6 and ES7 features and understand how now this particular feature in the asynchronous world work in JavaScript. Now we can make sense of how we can now write code that look like synchronous, that look like that we are writing is one after the other, to improve readability. And there's another course. Again, this is something that is might be off the topic. Important to mention that on the hard part, which is also our coming from ES6 and ES7 features that allow you now to write code that look like an object-oriented programming, but behind the scene is using is the object prototypal inheritance, or the object-oriented prototype, the prototype object-oriented. It is this inner mechanism that allows you to access to property and data from other objects. And that's something interesting. So in today's video, we're going to focus is on the generators. We're going to make a quick recap of the introductions as a way to recap or refresh our knowledge, especially on JavaScript, the fundamental of JavaScript, be able to articulate that in the most precise manner, understand the asynchronicity in JavaScript, how that plays out, how it was before ES6, and now how we can use the promise and understand the inner mechanism for that. And to understand now how we can write code to improve the readability using the async and await syntax by looking at the iterators and then generators, how they combine. The first is this new way of how you can access to data, whereas the generator is allow you to now have flow control over your data, how you're going to generate data, how combining those two concepts actually is what makes async and await work as it is. So let's get started. First, this introduction here is look at the JavaScript fundamentals, and that is, well, the thread of execution, evaluating the line after the another, the variable environment, which it can be global or it can be at the function level, which is now the function execution context, which is another feature. And then how now JavaScript keep track at which line of the code is currently evaluated thanks to the call stack, and how the call stack adding is function anytime it encounters functions along the evaluation, along the thread of execution. And these nice little bonus features that allow us is to write is closures that provide us is a way to persist the state of the applications when we return a function, or even if we return from a function an object that contains a function, we are effectively creating a closure for that. So that's something interesting, because we look now also that EX6 and EX7 provide other features that allow us to write now code more in a functional approach. So by using now this high order function, which is just a fancy name to say, hey, this is just a function that takes a function as an argument, a set of instruction as an argument, or return a set of instruction as an argument or a function, right? It can be both. And then how now, by looking at the arrow functions, we can now make the value of this, which is in language like Python or in C, now the value of this usually refers to whatever usually refers to where it was written, okay, as a way to access to the instance, okay. But in the case of this, in the context of JavaScript, it changed. It has several rules that depend on the context. It changed. So because we wanted to have now a more deterministic approach when we're writing our functions and using the this keyword, that's when we now use this. So what is doing the this keyword inside of a narrow function is to create a closure. So that's briefly speaking about how now we make sense of all of this, okay, the fundamentals. And then, well, now how JavaScript actually handle its task or instructions that we want to complete sometimes in the future. Prior to the EXs, we have the callback model, where here we got things like this for such functions, like timers that are exposed by the environments, whether it's on the browser or Node, where now the browsers say, okay, I'm going to expose these timers, and then you're going to pass me is a callback reference or a function reference, and then after that period of time, I'm gonna send it back to you. And the mechanism, the way of sending back to you is through the callback queue, where I'm going to add all of these callback functions when the time is passed. And with the event loop, which is a mechanism that it leaves on the JavaScript engine, it say, hey, this is now this code, or you can think of this as a person that is going to evaluate now is, if the call stack is empty, then let me take a look at the callback queue, grab one element, pass that to the call stack, JavaScript detect that in the call stack and say, oh, all right, now let me evaluate this. And once that is done, I'm gonna remove from the call stack and repeat the cycle, right? So once you understand this mechanism, which is also how now in the context of Node, how that works, Node has several different phases to actually handle different, particularly async operations. So you have now, and this is one of the powerful things of Node, is because now this, thanks to Ryan Dahl, it now provides us is a model, it's a thinking model where now we can actually run is, or we can actually run tasks, or we can now run is several tasks, okay, in a single thread language, okay? So that's the model that actually brings here, and Ryan Dahl put it at practice on the server. Because prior to that, we have, again, this is quite a little bit off the topic, just to recap here. So before that, we have now servers that are capable is to now handle this incoming requests and pass that to a process, okay? A thread of execution on the CPU. So you're gonna do that, right? This process actually works very well, but it's not that scalable, you know, because you will need now, especially if you want to handle more and more applications or more users in your applications, you will need to require is more and more hardware. This is known as the horizontal scaling. I think it is. Yep. Horizontal scaling. Oh, Code Roach Lab, exactly. Oh, okay. Exactly. The horizontal, okay. Scaling up and scaling out. So the vertical scaling, okay. Exactly. So vertical scaling, it means that increase the hardware for that, you know. So you can increase the hardware for that, or the other is that in the vertical scaling and horizontal scaling. So with the horizontal scaling is that you're going to add the same CPU, you're going to add more CPUs with the same system requirement. Okay, horizontal scaling. And if you can think this, is that if you, for example, using this kind of PHP application that actually take one thing and put that one incoming request and put that on the thread, okay, this particular model is actually very, very expensive, especially if you want to deal in large and handle huge amount of requests with high throughput. So the mental model of Node say, hey, okay, so instead of doing this, let me define some sort of mechanism that anytime that detect an incoming request or any async operations, input and output, usually is network operations or file systems. All right, let me now set this mechanism as a way to now detect when we need to process this, okay, and pass that to the relevant thread of execution. So we now can harness the full power of our multiple CPUs, and none of them will be idle. So Because of that, again, make a quick recap here. Now the event loop in Node has several phases to handle all of these different input and output or any of these async operations. Okay, so you have now first the timer phase, where it's going to evaluate the set timeout, and then it has the pending callback, where here is most likely evaluate is, for example, TCP errors, error connection with TCP, which is now the 4th layer in the OC model. This open system interconnection, how different computer systems with different requirements can communicate each other by following is this particular model, the OC model. And the transport layer is indicating is that, hey, this is now how we're going to send this data. It has 7 layers, that model: the application, the presentation. This is where you're going, the application, this is when it started to initiate the network operations. The presentation is that, hey, how are you going to send this data? You're going to encrypt the data. And the season as a way to establish now which type of connection you want to hold and which port it'll be used for that, the season. The transport, which now indicates which transport protocol we're going to use. It's TCP. It means is connection based, so the other one needs to be there before actually send something, or it will be UDP. I can send that no matter if there's someone else out or there. The other is now the network layer, to identify is that which address am I going to send this data, right? What'll be the route path that I need to take from this device across the network? Okay, the data link is when this establishes, for example, what'll be the communication across closer devices, like in a local LAN, in a local network. Okay, and then the physical one, which is now that we receive all of this data here, all of this instruction, you say, okay, this is now what I'm going to send over the cable as binaries. So that was quite interesting recap. Go back here, but describing is the different phases of yeah, to describe the different phases of the event loop in Node, the timers, pending callbacks. And you have is the poll, where here is when it handles this incoming request and how they're going to be processed. The poll, then you have this check, which is when you can use this set immediate, and then you have this now closing callbacks event, and then the closing callback when you handle things like close on a socket event, or like close event, close callbacks here, like socket destroy or the close event. So this is quite actually interesting, right? So on the poll is how long you should block the poll for the input and output. So this is all of these different phases, right? We got 6 phases. It also have other phases, but for those that are relevant for our code are these 6 ones. You have is now timers, pending callbacks, poll, check, and close callbacks. That's quite interesting, revealing, because now once we know how this callback queue works here prior to the access, now sorry, now we got is the features with promise that now is telling us, all right, now how can we now how can we, all right, make our life much more easy when it comes to read the code. Why is that? Because with the callback queue, okay, one of the issue with this is that anytime you want to write code that depends on another, you will have to write this code like this, which quite frankly is not improving readability. And in fact, our code doesn't look like that we are writing is that we are evaluating one after the another. Okay, so because of that, now the ECMAScript designers say, wouldn't it be better to have at least one object that only have is at one level, so we can improve that readability, and that is using promise. So promise, after all, it create an object in the JavaScript with a property, with a hidden property like state, in value, and unfulfilled and unrejected. So when that value or when that async operations change, or when that async operations is done by updating the value property, depending on which one of those was triggered, depending how this promise or how this representation of the eventual completion of an async task is done, if it is fulfilled, then it's going to trigger whatever callback you define on the .then or unfulfilled hidden property. You can take a look at that as the ECMAScript here. Okay, the ECMAScript here. So the ECMA, come on, promise. It's like promise object. Promise object, like this. But here we want us to take a look at the promise property of the promise instance. So once you create is this representation of the eventual completion of an async task, whether it's unfulfilled or not, okay, this is the property that it's going to have. The promise state, which initially is pending, okay, and when now that promise is being resolved or rejected, you're going to pass that on this hidden property, fulfilled reaction, which is when you're going to now trigger the callback that you define on the .then. But if there is an error, then it's going to now trigger whatever callback you define under the promise reject reactions, which is the .catch. So one of the things of this is that how now when we define this task and when that task is completed with an error or not, how now that actually communicate that to JavaScript. So when you're using, for example, another facade functions like fetch or read file or any functions that actually return a promise, what it's doing is that underneath the hood, because you don't have control about what's happening in this asynchronous task, you just only know if you receive a value or not, right? If you receive if there is an error or not. That's the only thing that you can do here. And because that is something that is outside of our control, that is actually handled by a host, okay, by providing these particularly functions, whether it's fetch or read a local file in the case of Node. The way of how now this works or how this notified to JavaScript is by adding all of these callbacks to or this micro task to the micro task queue. right? Which is another phase of the event loop, which has more priority than the callback queue. And it's going to evaluate is the event loop, okay? It's going to evaluate is the event loop if the call stack is empty. All right, now let me grab all of these elements one by one from the micro task queue until exhaustion. So if you can also define is micro tasks that will add it in the promise instance, or you can also add is micro tasks while evaluating micro tasks, which is something that you have to be careful because you might end up having an endless micro task evaluation, okay, and it never reaches to the callback queue. Some things there are some things to recap, to remember. All right, so now that we know that how callbacks, promise, web APIs, micro task queue, and the event loops allow us is to finally bring a synchronicity or make our life much more simple when it comes to write this modern JavaScript application. In other words, to write now JavaScript code that will now defer the work while in the background we are running other codes. While in the background we are running other code. This is actually something powerful. This notion here, because remember, at the end of the day, JavaScript is a single thread language. It's a scripted language, okay? And because of that, well, now with all of these features and tools, we are now able to handle this asynchronous operation. In other words, you can now actually take a look at your Wise account or your any bank account and get the results in real time. It's like, oh, that's quite interesting. This is my bank account, and I want to disclose that amount. So don't look at it, please. No. I know. So that's right. Okay, that's good, that's great, that's powerful. Now, even though the ECMAScript designers with the ES6 feature look at the promise and say, hey, you know what, there's nothing wrong with this, especially when you are actually running is multiple so for example, when you're running is that multiple instance for that, okay, which is, hey, I just wanted to now have a promise here, a promise, let's go to define some couple variables here. I can have is a promise one, okay, that this promise will now be a promise built-in object, okay, where now this promise built-in object will have is this shape. It is a function here, or in other words, where it received is a function with the value of resolve and rejected, okay, resolve and reject, which is now the callbacks that we want to run when something happens, okay, whether it is an error or not. So this is now the set of instructions that we're passing to this promise object, okay, here, and say, hey, I want you to now is, for example, after a specific amount of time, let's say is, so I want you to do is this. I want you to now pass a callback here and say, hey, this is a 2 second promise. You can say, hey, promise 1, 2 seconds, okay, and I want you to now run this after 2000 milliseconds. Okay, and not only that, okay, I want you to now return the value of this by saying whatever function or whatever function I'm receiving is the resolve callbacks. Okay, whatever set of instruction I'm receiving on the resolve callback, I want now you to run that after that period of time. Okay, so in our case we can say, hey, I want you to now is send this data. Okay, so when this is resolved, please send this data. And one of the beautiful things of the promise is we can now have control about not only the logic that we want to run here, but also where we want is to now trigger some of these callbacks, whether it's fulfilled, whether it is we get that we get a successful result or not. So then we can define is another promise here. Okay, let's go to define here is another promise here. In fact, here as you can see we're using is the new keyword, and what it's doing behind the scene is it's using is the prototype nature, okay, as a way to now have access to the prototype, as a way to have access to the property and methods through the dunder reference that points to the promise function constructor prototype. Why this is important, you may wonder? Because now here we are combining is the object-oriented programming as a way to represent something, in this case a promise, in this case an async task, and now we are using is the asynchronous nature of the language as a way to trigger something here, as a way to trigger this async function. So here we define now is this, say resolve and reject, that's right. Okay, and here we're gonna do quite the same here, you know, set timeout here as a way to avoid repeat ourselves. Okay, as a way to avoid repeat ourselves, we say promise to and again another promise here, promise 3 here, promise 3, this is another 3 seconds. So now the thing here is that with promise that all, we can now run as tasks that have, we can now run as async tasks that depend on each other. Okay, so here we can use this the built-in object called promise that has now is properties. Okay, that has now internal methods like promise at all, where now this must be is an iterator or an iterable in this case, something that we're going to talk about that later on, to take now a promise here 1 and promise 2 and promise 3. So this iterable, which this is one of the great things of now the ES6 features that provide us the iterator protocol or the iteration protocol, as a way to say, hey, this new particular protocol or way to accessing data, okay, which is not new, in fact, it's something that is exists in other languages, just the ECMAScript designer finally built in the language. But this particularly design pattern, as a way to know how can we access our data, okay, is quite important, because at the end of the day, we can now is by putting a badge or by identify is under the prototype symbol.iterator on square bracket, by putting this badge to an object, we are telling to the for of syntax, hey, this is an iterator, this object is an iterable. That implement is the iterator protocol, which means that when you're using the for of loop over the iterable that contains this badge under the prototype, okay, prototype on square bracket symbol.iterator contain this badge. Now this object must return is an iterator. This object must return in a standard way of producing sequence of data, and that is following is the iterator instance, which is you must return is the next value as well as the done property, the next function as well as the done property. The done property will indicate that, hey, you're done. Okay. So this is something very, very interesting, because now we can have is this particularly label to indicate to any object that use this badge, use this iterable, you're going to follow this particular approach, this particular standard way of producing. And that's something interesting and powerful, because now this iterator approach, which is a design pattern that regardless of how the underlying data is represented, the data structure is represented, we don't care. We just want is to go through all of those elements in one round, okay? Whether it is an array or a linked list or a tree or a graph, I don't care. We want is to do this. And that's something very revealing, because now again, this might be quite beyond the scope of his work, but I just wanted to show a little bit this piece of code. Let me actually do this. All right. All right. So one of the great things of this is that, especially on JavaScript, iterating through string, array, and objects requires a specific method to access that. You know, something that if you are familiar with JavaScript, there's nothing wrong with that. String chart that, hey, I want you to now access to that position in that string, or in the array, hey, I want you to now access to that position, okay? Or in an object, hey, because now this data structure is quite different in a string. In fact, it followed this shape key value, all right? Hey, I want you to now give me is the value of this. So I need to now actually get access to all of the names, get on property names, and then iterate through all of those names while actually calling is this object, or in this case, this hash map. Hey, give me this, give me this, give me that. So now with the iterator protocol, okay, not only we reduce is our code dramatically by improving its readability, but also we now have a standard way, and the power of a standard is, hey, you gotta love this. You gotta love this. The power of a standard, which is, well, ECMA is actually a standard, okay, from the ISO ECMA, okay, in the ECMA script, The ECMA letter stands for European Computer Manufacturing Associated. Okay, but as you can see, is that all right? I think organization in cooperation with ISO, but this is organization. But this is standard about ISO. um, hmm. Information technology, exactly. So well, again, this is the power of standards, of agreements. Okay, where now here we can say, okay, now let's make this any object here that following this particular batch, the iterator batch. Okay, now we know that this is the standard object, this is the standard response output that we're gonna get this, so we make sure of that, so we now have much more predictability of what's going on in there. And that's something interesting, because not only improves readability, which is after all that's what you want here, but also in context like what we have here, in context like this, okay, we don't need to actually indicate how we're going to iterate through this element, especially when you're passing that to another functions. We just say, hey, this actually implement this batch, you know what to do. So once you do this, okay, promise that all, and then then is when you now going to have is all of this value as it is, right? So because now you're gonna get all of this value as it is, okay, we can say is now, hey, this is the values, and let's get into this. Let's get into this. Oh, I didn't. No, because after all, this must be is a function. Exactly, this must be is a function that is going to receive the values there. And there you get it, right? And as you can see, you get all of this as a collection of them, and that's quite interesting. That's very, very interesting, because now you can get this data from all of these async operations. But again, the promise that all is it will wait for all, it will wait for all fulfillments, or the first rejected. So for example, if one of these actually reject, if one of these operations reject, like so, right? And here it say, hey, this is a new error. The thing is that now is on the dot catch is where you're going to actually get that, right? Not on the values. So you say error. This is now the callback function that I want you to run when something went wrong, as it is. Oh, the declaration of that, of course, is now complaining because it's saying, hey, who in the F is that? and then we get this, right? Another thing here is that unless we are very specific about which promise fails, the problem is that some of these operations might be performed. For example, like promise 1 and promise 2. But what if you want to actually roll back all of that? All right. What if you want to know is like, okay, I don't want to actually. Let's say you are now sending money to your mom, okay, and it needs to go through several banks API. You want to actually know is, or you want to actually is, do something that makes sense, and for some reason is the transaction went wrong. You just want your money. You want your money back. You want your money back. All right. How can we do that? There is also another convenient function that is the promise all settle, right? Which this function, it says, hey, I'm going to now, this is useful for any asynchronous tasks that don't depend on each other. They are independent. So if any of them fails, I'm gonna give you is all of this promise, all right, in which one of them fail or not. So now we will have way much more control of which one of them actually pass or not. And I think this is something important to actually understand, because now with the asynchronicity, if you want to actually roll back here, you can detect if one of them are rejected. Okay. So for example, here on the promise at all, if you want to check if one of them are rejected, all right, you somehow want is to do something about it. Okay. Let's say you want us to now do something like this. Hey, I want you to group by object dot group by, okay, group object dot group by, which is a fairly new feature in JavaScript. Okay, the items and the callbacks that must be an iterable. In this case, the items, values, and the callbacks, that is, hey, I want you to now group them by a particular element. Okay, I want you to group them by type. No, I want you to group them by status, or this is what you get is by status, right? As a way to, I'm retrieving this object and the structuring as a way to get only this property, this status, okay? And I want you now to evaluate that. So give me then by status. All right. This is also interesting because now with this group by, which is actually accepting an iterable, so the values what we're gonna get is in fact an array. Okay. I want you to now group. I want you to now look at each one of those elements and apply these conditions. So group by this values followed by the syntax. I want you to now do that. I want you to evaluate each one of them and return me those that contain the status. So organize or group them by their status. And that's all. So here, now when we run this, as you can see here, is this. we have all of them organized by fulfill, all right, which is their values. We're grouping by their values in an iterable. Hey, this is the fulfill. Hey, this is the rejected. Okay. Now we can say, oh, okay, all right. So this actually is quite interesting. This is a very interesting thing here as a way to group or an iterable and return an object from that. That's something quite powerful here. That's something quite powerful here. All right. Okay. So now, after that, we look at this particularly nice little bonus features and how we can make use of promise, especially when running is multiple promise at once. It's like, all right, now I want you to make this. I want you to somehow, for some reason, no, but I want you to take a look at the next step or the next topic here, which is the iterator. So with the iterator here, okay, yeah, with the iterator, we have now this ability to access to property and methods, and because of that, seems even though that we are creating objects, we manipulate data, we work with the data, but usually it's not with one object or one state, as they know is front-end development. It's like we usually are dealing with large collections of states or objects, whether it's an array, hash, or set, or map, linked list, trees, okay? So in our case, it's like, how can we know that any time that we run a function, we get the first element. We run the function again, we get the next element. We run the function again, the next one, the next one. So the idea here is to look at now how can we have access through a collection of data, which is accessing is a task in itself. Something that's one of the reasons why I actually show this piece of code here like this. It's quite a task to actually access. As long as you are familiar with, no problem. But in the case of iterating an object, it's quite a challenge of how you can now, do that. And the thing is that even though now with this iterator approach, is that we can think of data as streams of data, as a series of data, as a way of how we can access to our data one at a time. And by implementing this on own iterators using a closure as a way to persist the state or the inner state when we are iterating through a collection, by saying it's like, hey, let's going to define is the iterator here function. What you're going to receive is an array, okay? And now this, we're going to now, if we want us to iterate through a call in an array, we got is this. We need to first somehow keep track is the state that where we are, okay? Which position we are in this array, in this collection of data, whether it's an array or a string, or whether it's an array or a hash or a linked list or a tree or a graph, but it's important to understand that, okay? So function iterator the array, and then is this, because the way how now iterators works, they expect to call this function called next, okay? That this function is the one who's going to provide us is the next element, the next element, the next element on this collection, right? So by receiving is the array as a parameter, and accessing to that current value, and then store that value here, okay? Yep, and then store that value here. The idea here is that we need to, in the next time, or in this line of code, is increase is the index for that. And then say, okay, then return is the value. Because after all we want is to now create is a closure, which means that we want is to now have access to all of this lexical scope, all of this memory, so we can carry out in our backpack when we return this function. We say return the next here, okay? We can return this as an object, all right? We want to return is the next function. We don't want to invoke, we want is to pass is the reference. So now when we create our iterator, okay, let's say is the array iterable, we call that function, which is the iterator function, and we pass is our collection here as an array 5, 6, 7, and then we want is to now have access to the first element by calling next. We got that, and when we say, oh, we got 5, that's great. Hey, but I want to get is now the next element, okay, which is the array iterable.next. You got 6, and if you run this again, you got 7. And that's one of the powerful things of this, because again, now we can have access to our data using this concept of closure, which is pretty interesting. But because we need to look at a particular way of how we are constructing this iterators, because at the end of the day, they follow is a particular standard. The iteration protocol is made of the iterable as a way to put a label on an object to say, hey, this object in all of their elements that we're going to pass, now when you consume that with the for of, when you consume with this syntax will expect to say, hey, is this actually implemented the iterator protocol, which is another component? Is this actually implementing is this particular standard? And what is the standard? This object that must return is the next as a function, and the next as a function, and that next function must return is the value as well as the done. So if we want to actually make our functions iterator, okay, as a way to be recognized by for of loops, okay, by this syntax to say, hey, okay, this actually follow this particular syntax, good. You can think of this for of loop as like the bouncer at the bouncer at the iterable club, okay? So and this bouncer is like, okay, as long as you give me your credentials, I'm gonna let you pass. But if it's not, ain't gonna happen. This is pretty much what you can think of this. So in this particular function, let me actually redefine this function here. We can now say, hey, this actually implements the iterable protocol, but first we need to match this signature, which is, well, we're going to receive is now the value and followed by the done, which initially is false, so we're not done. But once we reach to the end, okay, then we wanted to do something here, or in other words, it's like, okay, all right, you say, hey, if the index is less than the array that we're receiving dot length, okay, now you can do this. So evaluate this, and that is evaluate this. Otherwise, okay, otherwise return please is this, which is you're gonna return is the value but done as true, as a way to talk to the bouncer, and in this case the for loop or any that consume that credential, and this is our credentials here, like so. And not only that, we, because after all functions are object functions type, which means that the function has the object size where it's under the prototype, or here is where you can define that. So our function here, which is an iterator dot prototype, I want you now to put this signature here as a way to others, as a way to now the for loops or any other bouncer that, or any other iterable syntax, that when they look at the symbol dot iterator, they say, oh, this actually follows this particular pattern, I'm going to behave in this way. Okay, so so instead of doing this, all right, we can in fact is get all of this logic out of this. All right, we can get our logic out of this, define this as a function where now we will have access to the I, but in this case we need to use is the new keyword, which means is that we're going to receive is, we're going to set is this property, because we're going to create this new property as an index, which initially will be 0 anytime we run this new iterator, anytime we run or we create a new instance here, 0, and then we say, hey, I want you to now make a reference to that, saying for this, increment that index, okay, and that'll be done. So now here with the symbol iterator, you say, hey, this label, this is this signature, and the signature is this function. So now when we want to actually consume that using the for loop, for use anytime you are iterating through this value of the array iterable, okay, I want you to now give me is, or print in console, it is values. So look at this. Array iterable is undefined. Might be. Oh, because exactly. I didn't use is the new keyword. I didn't use is the new keyword. So right there you got it. Array iterable is not iterable. I think this is the symbol iterator. Oh my god. Oh, is okay. Is in lowercase. Exactly. It's in lowercase. Symbol iterator is in lowercase. Oh my god. Exactly. Is symbol iterator in lowercase, and then let me now run the new keyword as a way to build these objects and automate the process of the prototype chains of access the property and methods under the by updating the dunder reference to what is relevant to the function constructor prototype. That now that prototype holds another reference to the object dot to the dunder proto. So the object prototype from the function constructor holds also a reference under the dunder to their base function constructor prototype. And that's interesting. To the base function constructor. So now this will work. Array is not defined. Oh, of course. Of course. Because now we have to make access to the this dot array followed by the this dot array, and there we got it. All right. Okay. Let me do this one step at a time. Okay. Okay. So now that we can define here our index and the array. Okay. Now we say, hey, this is the batch that you're gonna have. It's in lowercase, and then I want you to now update its reference to points to the relevant data of this instance. Okay. And now I want to create this object here, so you can iterate through that. That's interesting. Oh, of course, because we didn't initialize that array to be accessible here in this context. Array. Exactly. We didn't initialize that. So now this should work as expected. Oh, of course. It's not getting into that because now, as we mentioned, we got issues with the scope. So one way to solve this is by saying, hey, this next function here, it'll be an arrow function. Okay? This next function here will be an arrow function. And now we can easily correct this weird behavior of the value of this. And as you can see, look at this. That's way interesting because we actually apply a lot of this. a lot of this. So as you can see here, now we iterate through our collection here, and we're done. And we are done. So that's now the way of how you can define your own iterables here. And how interesting, how new is this concept, okay, as a way to now have access to that. Just pretty much what we did here, like so, right? So now this is very, very interesting. We implement our own, okay, we implement our own iterator using the new keyword, using is the hidden nature of that. You know, that's quite interesting. That's very, very interesting. You might wonder, hey, how can I now transform this into a class? Yeah, how can I transform the following code into a class? Exactly, unless you define that as it is. And I really like this particular approach, because we can say this is using this particular syntax, creating our first iterator, okay, iterator exercises, this is now implementing is the iterator approach, or iterator creating an iterator function in with new keyword, okay, and is this, and now creating an iterator function with class keyword. So this is pretty much quite the same here, okay, but in fact we're going to make access to that in this way. So this is now how you access to the prototype, okay. Any method that you define like this, they are now being added under the prototype, okay. Let's get into it. Let's get into that. So let's go to create now our iterator with a class. We just say, hey, class iterator, okay, where now this we can say is something like this. So it initially must have a constructor function as a way to now organize all of our data here. We're going to receive is the array. We're going to assign now is a public method called array, where now it can have access to, and then now the hidden method property. So how can we now access, or how can we define is this functionality in the prototype? Well, by defining is like a normal method in a class oriented programming. But in this particular case, we wanted to put a label under the prototype, okay. The way how you put a label onto the prototype, especially with the square bracket, is by now saying, hey, I want you to make the U symbol, which is useful as an unique identifiers for this particular tag, which is the iterator. Okay, and then now this is the logic that we want us to handle here. So in this particular case, well, define is the index here, initially 0, and then all of the proper logic that it needs to. For example, like now running is a next. Here, one of the great things of using is function with next is that the value of this will be lexical scope, right? That's the question, right? That's a question, right? So instead of doing that, we prefer to use the arrow function by saying, okay, let me now return, okay, but here I want you is to define is the index, not here, is here. Oh my god, no. Okay, but it's here, index as 0, all right, and then do something like this. Okay, yeah, and then do something like this. So because now this symbol iterator expect you to return is an object that follow is the iterator protocol, okay. So the thing here is doing something like so, and that is, well, we expect that this object return is the next, which must be is an arrow function. So we do now have access to that particular scope and evaluate this. So next, okay, must do something like this. I want you to now evaluate if the dot index is less than the reference of the array of this current object here, this current instance dot length, which is the data, the current instance, the current data that we are working on. Okay, if it is, okay, exactly, if it is, well, increase the index, all right, increase if it is, increase it is index, and then, okay, return is the object with this particular shape. As a way to make our code a little bit more as a way to now get the value here and to improve readability, we say, hey, this is now the value that we're gonna get from this. Okay, this is the value that we're gonna get from this. All right, and do something like this. So let's actually access to that. And when we access to that, I want you to access to the index as it is. That's all. Pretty much, that's it. All right. And now return is the value, and this property called done as false. Otherwise, then I want you to return is, well, the value there, okay, the value and done as true. All right, pretty much this is it. This is the way of how you can define how you can have access to the prototype as a way to put is specific functions there. And once you define this, now when it comes to use this, it's pretty much like here. When we say, hey, I want you to now use the class iterator, all right, and I want you to iterate through all of these elements as it is. Reference I is not defined. Oh, of course. Is here. And there you got it. As you can see, we actually have access to that. But this is now in the class version. So far, so good, right? Because now we were able, and I think that's very, very interesting. And I think that's very, very interesting. We were now being able to, well, use this, create our own iterator, and then, and here we are effectively creating is a closure here. Okay. Here effectively we are creating is a closure of the value of this, so it can have access to whatever is being defined here. So we define is that using the prototype as well as the class here. That's quite fantastic, I must admit. So when it comes now to look at the generator, which is now that we have looked at how can we access to our data using generators, and writing is the prototype as well as the class. All right, how now can we, okay, generate all of this data, this piece of data? So generator is a function that return is an object that satisfies is this iterator protocol. In other words, that now for of syntax can look at this object and say, all right, makes sense. Now the generator what allows is to produce or yield data when it encounters this keyword, this special keyword yield, right? Yield. This special keyword yield. So let's go to write it down here. There's a way to say that. And the generators allow us to produce a sequence of data without us to carefully managing internal state for keep tracking where we are producing. Again, it requires exactly, but it requires careful programming with the generators. Okay, the generator object is returned by a generator function, and it conforms to both the iterable protocol and the iterator protocol. Generator is a subclass of the hidden iterator class. So the constructor here, there is no JavaScript entity that corresponds to generator constructor instance of generator must be returned from generator functions. Exactly, must return from generator functions. Because the return is a generator object. There is only a hidden object, which is the prototype object shared by all objects created by generator function. This object is often stylized as generator.prototype to make it look like a class. Okay, to make it look like a class. But it should be more appropriate called generator function.prototype.prototype, because generator function is actually a JavaScript entity. To understand the prototype change of a generator instance, see the generator function prototype. This is on the generator. The prototype property generator function.prototype is shared by all generator functions. It is generator prototype, which is an object that follow is the iterable, which contains this label, the symbol.iterator, that you put under the prototype, as well as the iterator protocol. Output this shape, which is the next object that contains is the value and done among other properties there. So generator, this is instance property. These properties are defined on the generator prototype and shared by all instances. So you have the generator prototype constructor, the constructor function that creates the instance object. For generator instance, the initial value is generator function prototype. Note, generator object do not store a reference to the generator function that created them. Okay. Generator.prototype toString tag. The initial value of the toString tag property is a string generator. This property is used in the object.prototype toString. This is the instance method, and they must have the next, return, and throw, and then you got the examples here. An infinite iterator. This is one of the mainly widely used cases that generator is being used as a way to provide this value, an infinite iterator. With a generator functions, values are not evaluated until they are needed. With a generator functions, values are not evaluated until they are needed. Therefore, a generator allows us to define a potentially infinite data structure. This is basic examples. And when you take a look now at the iterator, iteration protocols, such object is called iterable iterator, doing so and an iterator to be consumed by various syntax. Therefore, it is seldom used to implement the iterator protocol without also implementing iterable. In fact, almost all syntax and API expect iterables, not iterators. Which is the label, not the iterators. The generator object is an example. It has a next method which returns the right result, so it is an iterator. Exactly, so it is an iterator. Function, it has an iterator method which returns the right iterator, so it is an iterable. All built-in iterators inherit from the iterator.prototype. Okay. Which implements the iterator method and return this, so that built-in iterators are also iterable. However, when possible, it is better for iterable symbol.iterator to return different iterators that always start from the beginning, like set prototype the iterator does. Like the set data structure, the async iterator and async iterables, building iterables, and building API accepting iterables. Promise at all, that accepting iterables. Promise at all, promise all settle, raise any, from, group by, map group by, interest. Syntax expecting iterable, for of loops, array and parameter spreading, yields and array destructuring. Some statement blah 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 blah. Okay. For await of loops and yield in async generator function, but not sync generator function, and there are only ways to interact with async iterables using for of array spreading, or an async iterable that is not also a sync iterable. And you can also have async iterables. Symbol.async iterator. Next, return and throw. There are another pair of protocol for async iterators named async iterators and async iterables. They have very similar interface compared to the iterable and iterator protocol, except that each return value from the calls to the iterator method is wrapped in a promise. Okay, so make it thenable. Okay, so except that each return value in next, each return value from the calls to the iterator method is wrapped in a promise. Okay, so you get me this value, but I wrap this into a promise, or it is wrapped in a promise. Readable string has symbol async method by default. Newly available, baseline 2022. The fetch API offers a concrete instance of a readable string throughout the body property of a response object. Okay. Okay, so now let's take a look at the iteration, iterators and generators. Exactly. All right. Except iterators and generators bring the concept of iteration directly into the core language and provide a mechanism for customizing the behavior of for of loops. For details, see also iterations protocol, for of, functions and generator, yield and yield. GL operator is used to delegate to another iterable object. Okay, such as generator. An iterable object. Okay. Because it's all about sequence of data. Mm-hmm. Okay. This is the iterator. Okay. So while custom iterators are useful tools, their creation requires careful programming due to the need to explicitly maintain the internal state. Generator functions provide a powerful alternative. They allow you to define an iterative algorithm by writing a single function whose execution is not continuous. Exactly. Exactly. It allows you provide you an alternative. It is an alternative to iterators. Mm-hmm. It is an alternative to iterators by defining an iterative algorithm. It allows you to define an iterative algorithm by writing a single function. It's an alternative to iterators. It allows you to define an iterable algorithm okay, an iterable algorithm so it allows you to define an iterable exactly. It's an alternative to iterator. It allows you to define an iterable algorithm or a iterative exactly, iterative algorithm by writing a single function whose execution is not continuous. It allows you it's an alternative to iterator, where now iterator it allows you to produce streams of data and how you can now have access to those data following as a syntax. But this is an alternative by letting you define an iterative algorithm whose execution is not continuous, whose execution is not continuous. 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 Us knows okay, continuous continuous. Okay, whose execution is not continuous. Continuous. Okay, nose. Okay. No. Continuous. Jesus, what the fuck with this word? Continuous. New os. New os. Okay. Continuo. 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 Continuous. Interesting, that particular word. Anyway. Alright.
Josh, line 1. Now we move on to, I said, once we rethink of our data as a flow of data, a stream, once we think of our data as flows, where we can pick off an element one by one, one by one, one by one, we can rethink how we produce those flows. JavaScript now lets us produce those flows using a function to set what individual element will be returned next. Unfortunately, before we get to that, we've got to go back to something which honestly is a little bit annoying. We do need to understand it for us to use the built-in function to produce flows.
Okay.
They don't call a function directly to return next element. They instead have an object with a function on it, a method, next, that when called will give us the next element. I want to build that from scratch ourselves, a final reinforcement of this model, but also to ensure we understand that this is just a function that's in an object now. But it's no different to what we did before. This should feel hopefully very clean review, but it will get us back up to speed before we move on to creating these flows using functions rather than underlying arrays of data. We're going to create a flow where we call a function each time, get the next element. Here we're doing it with a static, pre-built collection of data. In a moment, we're going to do it by yielding intermediate returns, you can think of those out, each of our next elements. Here it's going to be directly analogous. We're going to discover it gives us a lot of control over what those next values can be. Because now we're just running code to generate those next values. Very, very cool. But first, let's just be clear. JavaScript built-in return next elements, iterators they're called, are actually objects with a next method that when called, return our next element from the stream or flow. So we don't call return next element, instead we call the method on it. So return next element is now an object or a function, but it wraps a function. So we just call the function inside. But let's build it ourselves. Let's restructure slightly to make sure which... half the way across the page. Brand new...
Exactly. But then we take a look now at the generator function with dynamic data.
Data each time we call the function, so we wouldn't be persisting our data.
We find array and I.
Array's value is
4.
array. Josh, line 1, what are we doing?
Declaring a generator function.
Yep, good. Declaring a special type of function is magic new type of function JavaScript gives us called return next element, a special object. Josh, line 1, what are we doing?
Declaring a generator function. Create flow.
Yep, good. Declaring a special type of function is magic new type of function JavaScript gives us called a generator function create flow. There it is, special type of function. I've updated my diagramming for it. We'll start. Okay, next line. Not going to ask Brian, because I've asked him the same question as well, multiple times. I'm going to flip it up. I have an idea in my head about what question we'll ask each person. It's very interesting. Very interesting. Rick, what's the next line of code here to do?
You define a constant return next element, which is undefined right now.
Yeah, good. Excellent. Return next element, which is going to be the output of running. It's going to be the output of this call to create flow. What could the output of this be? Well, presumably, we're going to create an execution context.
No.
Probably. But no. But now, not in any meaningful ending it. What that means, I'm going to talk about in a second. Again, it's not like it's sitting there on the call stack. You get complete control over what the next element in that flow is going to be. Unlike when we built them using a baseline array, 4, 5, 6, that was set. We couldn't control that. We couldn't have logic determining what the later elements would be. That was just, it was what it was. Now we're going to get to control.
No, but the thing here is that, okay, because now with the generator you say this is a powerful alternative of the iterator where it requires careful programming. Do they need to explicitly maintain is the inner state? So far so good. But when it comes now to this powerful function, okay, that allow you to define an iterative algorithm whose execution is not continuous. Okay, it allows you to but this is from iterative algorithm. Only that makes sense. Okay. So generator functions are a powerful alternative to the iterators, where now they allow you is to define an iterative algorithm, an algorithm by going to one after the another, an iterative algorithm by running a function, okay, or by writing a single function whose execution is not continuous. Which means that you have much more control about the flow of data. You have much more control about the flow of execution or flow of data. Most likely it's the flow of data, because after all we are talking about is the iterative, and this particular pattern that comes from also other programming language like Python, the iterable protocol and the iterator protocol. And this is interesting because most of the time, we as developers deal is with large collection of data. So we need to find a way to actually make it easy for us to control how we are going to get all of this data and how we are going to produce all of this data. So the iterators is a powerful approach that allows you to now produce is data sequence of data, okay, and be consumed that by syntax like for of loops. The thing here with the iterator is that it requires careful programming, because you need is to define is because it requires careful programming because it needs you to explicitly manage the inner state. Where now with generator, which is a powerful alternative by saying, hey, I'm gonna allow you to define is this set of iterative. I'm gonna allow you to define an iterative algorithm, iterative, exactly. I'm going to allow you to define an iterative algorithm by writing a function whose execution is not complete, whose execution is not continuous. So, what does it mean? That is that if this function execution is not continuous, okay, but it allows you to now is to write this function for this iterative algorithm for this sequence of data. You can have now this particular function. What is a function? It's a set of instructions. It's a set of instructions that is not continuous. Okay? So I can somehow pause that. So by understanding what a function allows us to do, what a function is to encapsulate, to run this set of instructions. Okay? But now this set of instructions are not continuous, so we can now have much more control about where we are executing, okay? And this is good for iterative algorithm. That's interesting with the generators. In theory, when called, generator functions do not initiate execute their code. Instead, they return is a special type of object or a special type of iterator. And the iterator is the shape of this. It's this object that contains the next, that the next must return is the value as well as the done, as well as other property in the next at the next level. Okay, it returned this signature, which is a special type of iterator called generator. When a value is consumed by calling the generator next method, the generator function executes until it encounters the yield keyword. So again, this generators is a special type of functions that allow us is to write function whose execution is not continuous. Useful for iterator, useful for iterative algorithm. So for example, once you reach to this condition, stop. Okay. So once you reach to this condition, stop. Make range iterator for that. So allowing you to define is behaviors that will be much more harder to implement. The behavior of this code is identical, but the implementation is much easier to read. The function can be called as many times as desired and returns a new generator each time. Each generator may only be iterated once. We can now adopt the example from above, which is when we define our iterator like this. Okay. Like this. Using the iterator then looks like this. Exactly. To consume all of our data. But as you can see, the whole point of this is to now make it easy for us, especially with the generator, which returns a special type of objects, okay, whose execution is not continuous, like this. Even though it returns a special type of iterator objects called generator, okay, but now you can control which but now you can control which data you can return, which data you can generate. That's what they call this generator. And with the keyword yield, where it allows you to produce the result. And when that is done, you say, hey, return now the iteration count for that, or return the last value, or return that, make range iterator. Iterables. An object is an iterable if it defines the behavior such as what the values loop over in a for of. Some built-in types are arrays and maps. In order to be iterable, an object must implement is the add iterator or the symbol.iterator methods. This means that the object or one of the objects of its prototype chain must have the property with the symbol iterator key, which is this identifier, this label. It may be possible to iterate over an iterable more than once or only once. It is up to the programmer to know which is the case. Iterable which can iterate only once, such as generator, customarily return this from their iterator method. Whereas iterable which can be iterated many times must return a new iterator on each invocation. Because it returns a special type of iterator that can be consumed by for of syntax for that. So you can see all of the item that is now producing this is a special type of iterator generator. This example shows us generator iterators is iterable objects, which has the iterator method returns the iter itself, and consequently the it object can iterate only once. If we change the iterator method of the iter to a function generator which returns a new iterator generator object, iter can iterate many times. You can make your own iterables like this. User-defined iterables can be used in for-of or spread syntax as usual. Iterables. Advanced generator. Generator compute their yield values on demand, which allows them to efficiently represent sequences that are expensive to compute, or even infinite sequence as demonstrated above. The next method also sets a value which can be used to modify the internal state of the generator. A value passed to the next will receive by yield. Okay, so you can unmute exactly something that we saw yesterday. Here's a Fibonacci generator here. So you define your iterative algorithm for that. Okay.
What the later elements are going to be. It's going to require some really precise thinking to follow though, because it has a behavior that does feel weird. It's actually not crazy, but it does feel weird. Okay.
We are returning is a special type of object. It's okay. I'm just taking notes out of you as a way to improve my communication skills and that kind of thing. Okay. Yes, we're returning is a special type of object. Okay. Yes, we're returning is a special type of object. It's a special type of iterator object, which contain
So we're going to clear this code and go through this line by line, what we have up here. And then we'll do thumbs. I don't think there's much point doing thumbs before we get this dynamic piece out on the table. All right, so it's the return value of an invocation. That still makes people think when they go to return this element, I better go back and look and see create flows what's stored there. Create flow is never stored anywhere. Sorry, create flow's invocation, create flow friends is never stored anywhere. It's create flow is invoked. We do the work of it, whatever comes out, that's what's stored in return next element. Just to be really, really clear. So it's undefined for now to go do some work. Let's do that work. Return next element is the output of the call to create flow, which, Ben, do you remember what we said this returns out, kind of surprisingly?
An object with the property of next.
Yeah, known as a generator, object, exactly. A generator object with the next property, which is a method, a function on it. Good, all right. Next line, Ben.
We're going to declare constant element 1.
Just get my function, my object with the function wrapped on it. There it is. Yeah, declare element 1 Okay.
Undefined return value of function next element.
Yeah, which is a weird old return value. It's going to be very surprising. So, element 1 is the output of return next element dot next, cool, which is just this function here being called, the one which we returned out on this object and stored in return next element. This, though, is a command to begin the execution context of what, Ben?
Create flow.
The create flow
The
execution
create flow.
context. Okay, so we open it, and it has a memory. There it is. And inside of it we go. And what's the first thing that it says to do inside Brian?
You declare a constant named num, assign a value of 10.
Great, there it is. Okay, next line says to do what, Brian? Left-hand side first.
Create a constant called new num.
And saw that in memory initially.
Mhm.
Well, we're going to see. So, new num is going to be the evaluated result of the right-hand side. It's
Of
always
the
the
right
case.
side.
If the right-hand side is just a number, a value, you just saw the number there. That right-hand side ain't a number, it ain't a value. It's actually a command. It's actually a super powerful command. So yield num, which is 10, it's actually a super powerful command.
Yield.
It's a command that's going to
Which
throw us
Produce.
straight out. It's going to throw us straight out this value, straight out of this execution context. And Ben is going to have that 10, that output be the result of what?
New num, which will be
No. Yeah, exactly. We declare new num. But yield is so powerful. The right-hand side is so powerful that it's a statement to just throw you out of the function. We're never going to get a chance to store something in new num. It's undefined for now. The right-hand side, we always do is you declare the left-hand side, new num, and the right-hand side you then want to get to a value that you can then store on the left-hand side. But the right-hand side, we don't have a chance to give it a value, to evaluate it to a value, because it's like seeing return 10, like a super powerful keyword, that just kicks out this 10 as our output into the return next element dot next. So what does return next element dot next evaluate to, Ben?
10.
The 10, exactly, which gets stored in
Because it's
where,
going
Ben?
to produce
And
that.
1. And in this execution context,
It's like
you don't
yield.
want to assign anything.
Yield. Okay.
This has been paused just before this right-hand side can evaluate to a value and be stored in new num. So in our execution context,
And now, okay. Because this yield, okay, it's because this yield allow you is now not only to produce result or produce or give it back its expressions, but also on the next time when you receive arguments, you're going to receive that. Which is 2. All right.
new num is still undefined. Let's hope we get a chance to assign it.
So, okay, when we're running this, we say, hey, getting here, exit. Getting here, exit. Getting here, exit. Exactly. Getting, exit.
New num something. Let's hope. Okay, we're back out to global execution context. This execution context is pause. We'll talk about what pause means in a moment. I don't like the term pause. That's definitely a fake for what actually is words, but what does it mean to pause a function? What is an execution context? Let's give you a preview. Execution context is just state, memory, and what line am I currently on, in what position. That's all it is. And the thread is actually in it, as opposed to not in it. The thread has the function line has control over the thread. Other than that, that's all it is. Position in the code and a memory. That ain't that hard to save in the next function. Or sorry, it's attached to the next function. And that's all a pause execution context is. It's the closure, the backpack, but now also the position in the function's execution. So we can come back and continue running. That's all we're going to say. We'll talk about that in a bit more detail in a moment. But for now, we're back out to global where, Alec, what's our next line? This was our previous global line. What's our next line of global code?
Define element 2.
Excellent, give me a second. Element 2 is going to be return value of calling what? Function. Being kicked out and never getting a chance to find an statement in of the pre-2, it's line of, and beautiful it is to have control over what, to think about data as flows of values, flows of elements, because we can literally control dynamically what the next element of that flow will be. Is it having our element 3?
We would have
You do 5 plus 2 for the previous one. What's the next one, Brian? 6. Excellent. Exactly. That very one at the bottom there. All right. Thumbs on this. You lost me. It's okay. This stuff's super hard. Very, very clear. It's a brand new feature. It's ES7. Clarification. I didn't use to put var. I didn't use milk for var for a long time. So I didn't want to explain cons and let. And now we're doing pure ES7. All right. Brian has clarification. Ben has one. Victor and Paul. All right. Brian has clarification. Ben has one. and now we're doing pure ES7. All right, Brian has a clarification, Ben has one, Victor and Paul have one, Josh is in the middle. Let's start with Victor.
So I guess my question is, maybe this is one of those other ones that should be left for later. What is this pattern after? Where is? I mean, I feel like it's very new to me.
Other languages have iteration generators. Python has them. Like they're a pretty standard. I know they're standard, but they're a pretty nice. I'm gonna say somewhat more contemporary because traditional computer programming is very imperative. That is all about saying I'm going to show you exactly how I do every last thing I do. And as we go through time, we develop a more abstract model where we talk more about let me do what I want to do, as opposed to, for example, here, what do I want to do? I want to literally get my next element one after another. That's a very I'm not showing you how I'm getting it. Well, there's something similar here, but they're in Python, at least, and so they're not completely, by any means, new. Ben?
Write a function with console log hello there or gibberish every 3 seconds, depending on if the word passed into the function is English.
Or profoundly from being the object that the JavaScript is actually returning with a value 10 and done false to being the 10. But Ben adds a very important clarification here that's going to help with your familiarity when you see the actual code. We actually return out an object with the 2 properties. I mentioned that before, but again, it's just much more readable here for our purposes.
Hello there or gibberish every 3 seconds, depending on it.
Great question, Ben, or great helpful clarification. Paul?
Note the penultimate yield waits for 5 plus nunum.
Write a function that will console log there, hello there, or gibberish every 3 seconds, depending on the word passed into the function. If English, do not use any type of loop construction and only make the call to create conversation once.
Go inspect that, dude. I mean, you're going to see that actually it's got a whole bunch of these built-in generated location. They're stored on the object. If we were to build this out ourselves, we'd probably store it. I suppose we could store it on the object. We'd want to store the cache of data though, probably in.
Write a function that will console log hello there or gibberish every 3 seconds, depending on the word depending on if the word passed into the function is English.
Generated location. Actually, scope is stored on the object, but it's only because under the hood it is. It must be still attached to the function if it's implementing closure itself, but it may be an
every 3 seconds, depending on
it's
that.
Stored as a square bracket scope property with that data, and it has a property called status suspended when it's not executing. It has a property generator location itself, which refers to where is the generator defined in JavaScript. That's like 5 or 6 properties. Okay.
Does it have throw on it too?
It won't be on the object itself, but it could be on the prototype or the generator object type. Okay, any other clarifications? James?
Number one, I see this as super powerful because you could certainly have a generator that's essentially an infinite loop as long as it keeps yielding.
Oh yeah,
As long as
that's
it
very, very
keeps
true.
yielding.
That's one of the most powerful features of these, yeah.
Times or Fibonacci calculations.
What a great insight, yes, absolutely. It's one of the most powerful things about this design.
And number two, I assume the shortcoming here, which likely leads into the last topic, is this is synchronous code, however, right?
Well, let's see in a moment what happens if we were to instead yield something that is an asynchronous task being set up. And that's our very final piece. Before we get to that, I think it's worth doing one more block of pairing, just almost to give ourselves a little breath of fresh air even in the meantime, but also metaphorically so. In other words, go back to the challenges for a bit, just to test yourself out on this material. Those last challenges 7, 8, 9 are this material, but in a moment, we just said this return next element is a special object. There's a next method which starts or continues running create flow until it hits yield, returns out the value being yielded. We end up with a stream flow of values that we can get one by one, but we get to control them dynamically. But we're going to see, most importantly, for the first time, we get to pause, pseudo-suspend, a function being called, and return to it back into create flow using return next element.next, calling it. Just so I'm going to give a little preview. In asynchronous JavaScript, we want to be able to initiate a task that takes a long time, for example, requesting data from a server, move on with regular synchronous code, and then come back to run further functionality on the data that comes back from the slow asynchronous task. What if we were to yield out of the function at the moment of setting off the long time task, the slow task, and return to the function only when that task is complete? We might finally get a model of thinking about asynchronicity that reads logically to us. We're going to see it after this pair programming break. We're then going to wrap it, we're going to build it ourselves manually, we're then going to wrap it with a brand new construct known as async await. All right, people, here we go. Back to your pair programming. We'll reconvene in 10, 15 minutes. Return next element.
So it's like you're saying, hey, yield. You're going to say, hey, if the string match if the string match English, well, I want you to now yield this. Yield is a string. Yield is set timeout of this callback function here, which is, hey, you know what, let me do something like this so you can see what I'm doing actually. You know, it's like open up here the iterators, all right, and then now copy and paste this particular code that I have here on the iterator exercise here. Okay, and I'm going to move on to the value and brief value. Actually, I don't care about that, right? So we can comment that out here, because I care more about is doing this particular challenge here. Write a function that will console log hello there if gibberish. So you say if the string match, if the string match to English, all right, then I want you to do is this. I want you to yield. I want you to yield this set timeout with the. That's quite interesting, because if I yield from here, at the end of the day, I'm going to now run this callback after that time. Okay, that makes sense. And you say console.log hello there, hello there. So it makes a lot of sense. Yield for that. After 3 milliseconds. All right. Otherwise, yield now that, but with the word of gibberish. Console log gibberish. So when I run this, 2019, when you say, hey, string match, comma, like this, say hello there. Exactly, it's because I need to, yield is here. It's not only once. Okay, as a way to only do this. Oh, of course, it breaks that because it's this and it's this. Exactly. Now it'll do that as supposed to. It'll yield this. Okay, so now that's quite interesting, because now we are able to say this, hey, generator function, I want you to now yield this asynchronous task, is this timer, whenever we called it. In other words, I want you to now add this callback functions to the callback queue, okay, whenever we call it. And when something now happens, or when now we have oh my god And when now we have that value, all right, let the event loop process that for us. So pretty much what we're doing is the same with the promise here, and that's something interesting. Oh my God, that's powerful, because look at this. You can say it's gibberish. You know, we are now capable of deferring this function, which to me is quite powerful, quite interesting. What the is even this? I don't know, get the hell out of here. Anyway, but so the idea here is that now with yield, we are capable. Oh, okay. Oh my God. Oh my God. Those people actually are. Again, all of this is just for specific use case. Mm, 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 mm. Oh, mother. Okay. That's actually very, very interesting. Holy moly. That's actually very, very interesting. So we can now have this particular function that what it's doing is to talk to the event loop, whether it is you're using it with a callback or with a promise. And now by running these functions, you say you can communicate with this hidden nature. You can communicate with this inner mechanism, with the promise or the callback. Hey, I want you to now run this. And once you get that value, give it to me. Holy moly. Okay, okay, all right. Jesus, nigga, what? Nigga, what? Holy moly. Nigga, what? Nigga, what? Nigga, what? Okay.
Especially that function, and then continue executing it by holding on to the memory in that function execution context and the position in that function execution context, and then returning to that. His yield returns out the value being yielded, pauses, or sort of exits execution context, just holds on to it here. We end up with a stream flow of values we get one by one by running return next element dot next. Next element,
I prefer to
next
call
element,
them is flows of value.
Look how dynamically we control what they are. Every time we say yield keyword, the next thing is this expression that's going to evaluate to our next returned, or our next element in the flow of elements coming out of our flow. And those flows, those functions that give us the next element from the flow are known as iterators. Okay, there we go. All right, anything that gives us a flow, element by element, is technically known as an iterator. I prefer to think of it as being a flow of elements that we just grab one by running a function. Switch on the tap, getting the next element, switch on the tap, next element. But here we're producing that flow by running through a function, hitting a yield statement, giving that as the next element of the flow. Continue, yield statement, next element of the flow. Go back in, continue, yield statement, next element of the flow. We're now running functionality to generate our next element of our flow. That also means we get to control the return manually ourselves into a function execution context. What method then do we call to initiate us going back into the execution context?
Next.
Next. We now have manual control of how to return back into a function execution context for the first time ever. All we needed to add, by the way, was the ability to track the position we were in. Probably some other stuff I'd look to do that. But that's essentially all we're adding. We're very used to persisting state from a prior execution context as a backpack of data. Now we also persist position at which we exited the function execution context to allow us to head back in. But that's super powerful. We're now getting to suspend a function being run and then return to continue running its body of code by calling the next method that takes us back in. We manually control when we return back to run code. So what if we could use that to handle asynchronicity? we could initiate a task that takes a long time, for example, requesting data from the server, set it up, use the yield keyword to have that as be the return promise object, be stored out here in some way, and throw us out in the execution context. Then continue, throughout the execution context, continue running through our code, including attaching some functionality to be auto-triggered when that promise gets its value back. And what if that triggered functionality inside of it contained a call to next that took us back in to continue running our code, with its value being passed back in, the value from the return request, the response object that came back into the promise value. Wow. And that is exactly what we're going to do here. We can use the ability to pause create flows running, and then restart it only when our data returns. We get to control when we return back to create flow and continue executing by.
Because this is the way how you can create now is an awake and a sync min. So yield that, all right? So yield this, and when we get that, anytime we call this, which is returning as a promise, okay? And now this promise, okay. And now this promise we can is now now that we get this promise, okay, which now we can is pass a callback function that is gonna get the value of this. Do when data receive. And when data is received, which is the value of this fetch method, we're gonna now run is return next element dot next. Okay, we're gonna now is to run is the next promise.
Setting up the trigger to do so, which is the next method, to be run by our function that was triggered by the promise's resolution when the value returned from Twitter. It's a little bit of a sort of loopy back and forwards. It's all going to be automated by async await. We're going to build async await from scratch using this generator function concept. And then we're going to sort of tidy it up, wrap it up using async await. We're just going to automate a few of the pieces.
But now I understand why is okay. It's because it's now communicating is to the micro task queue as a way to say, hey, I want you to now do this, okay? So pause the execution of this function, all right? So yield that and pause the execution of that function, and when that data is available, now resume the execution of this.
Last two slides are our final. Line one. What are we doing? Sean.
Declaring a new function do when data received.
Oh, okay. So the async and await, what it, after all, is a generator function. God damn it. The async and await is a generator function. Async and await. Okay, this is a generator function. Async function declaration creates a binding. It's an association of an identifier with a value. Okay, it's a binding. Associate the value, is associate the label or an identifier with the value of a new async function to a given name. The await keyword is permitted within the function body, enabling asynchronous promise-based behavior to be written in a cleaner style and avoiding the need to explicitly configure promise change. You can also define its async using the async function expression. But after all, this async function expression can be used to define an async function inside of an expression. You can also define async functions using the async function declaration or the arrow syntax. It takes the name, the parameters, and the statement. And the statements. An async function expression is very similar to and has almost the same syntax as an async function declaration. The main difference between the async function expression and the async function declaration is that the function name, which can be omitted in the async function expression to create anonymous function. An async function expression can be used as an immediately invoked function expression, which runs as soon as it is defined, allowing you to mimic top-level await. To see also about the functions chapter. But at the end of the day, this async function these async functions or built-in objects like this, they are generators. And the async function object provides methods for async functions. In JavaScript, every async function is actually an async function object. An async function. And then you got this built-in object, the async function, which contains the constructor and the toString, and that's it. Inherit instant method from its parent. And await. The await operator is used to wait for a promise and get fulfilled value. It can be only used inside of an async function and a top-level model. Expression of promise, a tenable object. Attainable. Await is usually use an unwrapped promise by passing a promise as the expression. Using await pauses the execution of its surrounding async functions until the promise is settled, that is, fulfilled or rejected. When execution resumes, it's using behind the scenes is a generator, but it's like inside of this function you are a generator. So anything that is here, you're gonna yield that, or you're gonna run that, okay? And when that time in which you get that value, all right, you're gonna return that for you. When the execution resumes, the value of the await expression becomes that of fulfilled promise. If the promise is rejected, the await expression throws the reject value. The function containing the await expression will appear in the stack trace, okay, of the error. Okay, if the promise is rejected, the await expression throws the rejected value. Exactly. The function containing the await expression will appear in the stack trace of the error. Otherwise, if the rejected promise is not awaited or is immediately returned, the caller function will not appear in the call stack. The expression is resolved in the same way as promise.resolve. It is always converted to a native promise and then awaited. If the expression is native promise, which means the expression belongs to the promise or a subclass of expression constructor, the promise is directly used and awaited natively without calling then. Then objects, including non-native polyfill, proxy child class, etc., a new promise is constructed with the native promise constructor by calling the object then methods and passing in a handler that call the resolve callback. Non-tenable values and an already fulfilled promise is constructed and used. Even when the use promise is already fulfilled, the async function execution still pause until the next tick. Okay. In the meantime, the caller of the async functions resumes execution. See example below. Start, middle, end, full first and second. So when you run this, you say first start, middle, end, and start, middle, end. Control flow effects of await. When an await is encountered in the code, either is an async function or in a model, then awaited expression is executed, while all the code that depends on the expression value is paused and pushed into the micro task queue. Exactly. So, while all the code that depends on the expression, in this case this, while all the code this, exactly, while all the, which is the callback here, is pushed into the micro task queue. The main thread is then free for the next task in the event loop, and this happens if the awaited value is already resolved promise or not a promise. For example, consider the promise, because after all you what happened here is that it's being added to the micro task queue here. In this case, the two async functions are synchronous in effect because they don't contain any await expression. The three statements happens in the same tick. In promise terms, the function corresponds to, you call this function and then you wrap them into, exactly, it's like you create this new promise by adding to that. And when you run that again, you create a promise, and then once that is done, well, you're going to add that to the micro task queue. However, as soon as there are one await, the function becomes asynchronous. An execution of following statement is referred to the next tick. Exactly. However, as soon as there's a one await, the function becomes asynchronous. An execution of the following statement is referred to the next tick, which is, it's going to evaluate now star, okay? It's going to evaluate, because this entire promise is going to say, this is an entire promise. It say, hey, let me evaluate this name, and then I wait for the middle. And then, okay, and then I wait for the middle. Interesting. First start, first middle. Then he evaluate the next one. Okay, we have to wait for this. He say, okay, this is going to evaluate like synchronous, but now this becomes asynchronous. So I'm going to evaluate this. This becomes this becomes asynchronous. Okay. So I need to pause the execution, adding this to the callback here. It's like you're adding is a promise here. Okay. So I'm going to now evaluate is the next line, which is the second, and say name and star. Okay, and now that I have evaluated the entire call stack, I say, hey, I think I got a couple of things pending, and that is the first middle, which is after this, then this. This corresponds to this. The new promise is resolved immediately, and then when that is resolved, holy shit, Well, the extra then hard handler is not necessary, and a handler can merge with an executor passed to a constructor. All the microtasks can execute before the async function resumes. Holy moly. Q microtask. This is a function. Q microtask here. And then you have the async. And you have the Q microtask here. Console log script. So now it's going to evaluate is this. It defines this function. In fact, you are running this function. Exactly. You're running this micro Q task here. And then you're running is this function itself, and then this. So you say, hey, let me now evaluate this micro task here. Okay, which is a micro task. And I'm going to now call myself, okay, test, which is a function, okay, okay, I'm gonna call this here, micro task here, this one. Okay, immediately invokes has higher priority. Immediately invoke has higher priority than this. So you say async function star await null. I'm going to pass this to there, to the micro task. I'm going to continue to where I'm going to pass this a new null to that. Okay, and then console log async function ends. Script sync part end async function star. Okay, it's not going to evaluate none of this or this. This is now calling is this micro task queue. Okay, console log queue micro task after calling async function, and then the console script sync part end. And now it's going to evaluate whatever you put in there first. Which is running this, a Q micro task here. Which is micro task 1. Call micro task here. And then resolve is the async function here. What in the F? Improve stack trace. Okay. Jesus. Anyway. Holy moly.
Who, when, data, received. Oh, folks, this is my favorite page of code ever. This page of code is going to bring together everything we remember from our web browser features, everything from our new generator functions, our micro task queue, our event loop, our crazy new generator functions that include our persistence of states, what you might call closure, all in one beautiful, complete setup. Huh. Very special. All right, good. Function 1 declared. Rick, next line.
You declare generator function create flow.
Excellent. Well done. There it is with a little star. Okay. Next line, Alec.
We declare constant return next element.
Excellent. Thank you, Alec. Undefined for now. Oh, here it goes. Here it goes. All right. The diagramming, the mega diagram. I'm going to put my call stack think there's room to do it here. I'm going to put my call stack here. I think there's room. But in what context we're interested in. That's a method which, when called, should give us out our next value from our flow of data. Now, we can already see we've only got one yield.
Where the flow is generating is this object. This generator object. What it contains is this iterator protocol.
Next line is what, Ben?
Declare a constant future data.
Yeah, just make sure we're in the global execution context. Declare constant future data. There it is. This really does bring it all together. So we're going to be precise as possible. Future data, which is the output of
This is the output
return
of
next element
dot next, which is now when we call here, we create the
what execution context?
create flow execution context.
Create flow execution context. There it is. In it goes. Oh, by the way, notice how my execution context now I don't close them, right? Because I'm not going to exit straight out of them. That's what I've done for both. I didn't know what to say. Okay. So return an element dot next. Because next has this bond to create flow, I start executing it. Into it I go. And what's the first thing that I declare in my local? That's too wide. I declare in my local memory. I'm calling create flow. What's the first thing? My first body of in the body of create flow. Exactly. The first thing I declare is data, which is, again, I'm not correcting anyone's pronunciation, which is undefined, right? We're going to go to the right hand side, and the right hand side, of course, is a super powerful statement.
Data.
It's one that's going to actually kick us out
Data.
of
Data.
create flow's execution context before we ever get to store anything in data.
Data.
Let's make it
Okay.
slightly wider. I don't want to squeeze this.
This
too
is
much. It's slightly
data.
wider. So
Data.
is going to be the
Data.
evaluated result of the expression yield.
Yeah, what is
fetch.
data? No, it's data. Data.
Let's
Data.
wait for this.
Data.
Yeah, there it is. And fetch
And
is
now-
a function that is a facade for a whole. You see, that's what we're going to come back together.
For a promise.
For a whole bunch of,
Mm-hmm.
well, for a single element, undated.
So, but for all this
Okay,
is a
and it's gonna be
promise
thrown out,
here
it's gonna be
that is going to
stored
return
where
to the fetch data.
is
What we can now
empty array
subscribe
functionality that will be triggered
is
for
the
this complete
functionality
and pass
that we
value
want
to
when those
this function
functionality
object.
are
So it's
completed
through
here.
that already. It threw this expression of stuff feature thing update function or log it yeah as an input that this yield statement, this function is going to be triggered with the value as its input, and so whatever we pass in to next is what the last yield statement on the right hand side will evaluate to, and so we get to evaluate to high our data that came back from the internet, pass to value, pass to the do when data received, pass to the next inside of there, pass back to be the evaluated result of the yield expression. My goodness. And we're going to store that blessing as what constant inside of create flow.
Data.
Exactly. And there it is. And then we get
Data.
to continue in our pseudo-synchronous execution context
Data.
thread. Thread gets to continue through our create flow. And what's the next line we hit then?
So on data.
And it's the high. And look at that, people. I genuinely think this is absolutely beautiful. For the first time in history, we get to continue. We get to exit a function. We get to show code that I want to do to set off a long-term task. Then exit out of the function, continue with synchronous code, and then when that long-term task value comes back, trigger is going back into the function and continuing within that same function block. Now we get to think about our code that's deferred, the console log, to be run until we get data filled in with an actual value. We get to write it immediately below, in logical steps, the code that kicked that work off. First time ever. All right. So this is profoundly hard. And you can see it brought everything we've done together. But let's have thumbs. In a moment, we're going to clean all of this up. We're going to auto-trigger, not a function here. We're going to instead auto-trigger the next block of code in here. We're not going to trigger a function that then triggers us going back in here. We're instead just going to trigger straight from here, continuing our code inside the function, using a new way of defining our generator functions called async await. But before we get to that, you lost me, and it's okay. I'm clear. I have some clarification questions on this new model of execution. Everybody thumbs proudly out. It's okay to have. Alec has a clarification. Abdi has more than a clarification. Brian has a clarification. Brian, do you want to go first?
Yeah, so this is still asynchronous when you get down to the end. We're still adding everything to the test.
It is.
So if there was like a console log after that would go first.
Absolutely. I should have done that. If I had a console log straight after storing the do when data received on the then, on the future data on fulfillment array, and a console log straight after, all to happen. If I were to block my thread here, after this assignment of do when data received to future.data's on fulfillment array, if I were to have a blocking task there for or a while loop that's infinite, then my do when data receive that triggers inside of it entering back into create flow, I'd never reach that because that's on my microtask queue. So it's still absolutely asynchronous. All this is doing, you can almost think of the code console log, you can almost think of everything after the yield statement that throughout the tasks, throughout the promise object for your data. You know, everything like this as being like the functionality we want to run on the data coming back. Almost think of this as being
Okay.
pass.
The functionality we want to run
This-
when the
this
data is
here
back.
that functionality run later. But now we get to go and run it. We get to write it as though it's synchronous code in a function. We just come back to it only when we trigger running do when data receive, which we then get to manually set. Now I get to go back and run this code. It's the most control we've had probably over when our deferred functionality runs. But in the end, it's still, as by the very nature of asynchronicity in a language, beyond our control. Because what triggers return next element dot next running that takes us back in here? What triggers it? It's the beyond our control setting of value property that beyond our control triggered do when data received. But now when we trigger that, we just write inside a command that we did get to control writing that takes us back into this function. But the very nature of a single-threaded asynchronous language is that you throw out tasks in a single thread, you throw them out, and then they come back in and run functionality on the return values beyond your control. That's the very nature. And that's why in the end, solution 2, which was the callback model, in the end it's also true. In fact, it's not a wrong model. Under the hood, it's the same thing. Under the hood, we're not doing profoundly more here. You're just increasing readability more and more. And in a sense, by doing so, hiding the underlying engine more and more. And that's arguably a problem if you don't understand the underlying engine. If you do, now you get best of both worlds. Increased readability and the ability to understand how it's truly working. Async await simplifies this entire process. Async await, I would say finally fixes the inversion control problem with callbacks. Actually, this does as well. Async await, we're not going to need to have a function here that triggers the return back into the generator function execution context, the create flow execution. We're not going to need that anymore. Instead, what's going to be triggered from here is just come straight back in here with the return value. No more triggering of that happening via another function. We're going to walk through it line by line, and this is our final code. We're running slightly long. This is our very, very final code of all of hard parts, all of the beauty of asynchronicity. By the way, though, can we just appreciate for a second, or appreciate yourselves for a second, you've incorporated into your mental
A
model
lot of mental models.
every hard part of the JavaScript engine here. The entire web browser features part, the microtask queue, the only person who talks about microtask queue really is a guy called Jake Archibald, truly gifted. I highly recommend him. Brilliant British speaker who's a developer evangelist at Google, truly gifted explainer of concepts and sharer of entertaining, humble anecdotes, as is the want of my people. And he talks about the microtask queue, the only person who does. That's how advanced this stuff is. And you've combined all that with a feature of JavaScript in ES7 that only just got released. Generated an async await. And you built async await from scratch. This is async await. If you get a senior dev interview question, which is going to come up more and more, I think, can you build for me async await from scratch? You just did it. You just built async await from scratch.
Just built Redux Saga, basically.
Even better, you just built Redux Saga from scratch. Let's try and inflate our
Redux
achievements.
Saga from
We
scratch.
just built the JavaScript engine from scratch. There we go. I feel particularly proud of all of you. All right, so we're going to do this though. Final
Redux
code
Saga.
is going to be doing the nicely, prettily wrapped version of this using the async await or the async function declaration style, which is going to just print a
Barbering pregúntame. all for this video. Take care.